Thanks for joining us. This is Nick Bubich with Veriphase. Today I'm going to be doing a brief overview of the ADT Pro workflow environment, just to give you kind of a general overview before we get into each individual component in some of the subsequent videos. So with no further ado, we will go ahead and get started. So when we just first designed ADT, and as we continued to build upon it, we really try to focus everything we do on some of the challenges we've seen when it comes to phased array data analysis. I've kind of bulleted out some of these more generalized things that we run into. A lot of what Veriphase does is third-party data, quality assurance, verification of calls, that kind of thing. So we know the real challenges out there, and we kind of see that from all different types of sectors, and the people actually doing the inspections and the people receiving the inspections. So we've tried to kind of characterize those and then try to build a product that helps relieve some of those issues. So if we go through those real quick, these are pretty generic, and some of the videos will go into more detail on specific issues, but these kind of get to the heart of some of the challenges that are out there for everybody. So one, that the scanning is really quick, but when it comes to the analysis, it can be really slow. Anybody that's been sold phased array services, someone comes out, scans your weld, and that's kind of a lot of times where the demo ends. But the reality is, especially if you have multiple groups, high resolutions, phased array and Toft, all these different things, large diameters, the analysis can be quite slow, and the burden's really put on the technician to get through that data. And you never want NDT to be the bottleneck, and schedule is always king. So that's a key one for us. Also quality. So quality can vary from one technician to the next, and a lot of the data out there is bad. So when you're going out to buy phased array services, how do you know one vendor versus another, the technician he sends on day one versus day two? And really the codes have some basic guidelines for how much training you need, but if you look at them closely, they'll put classroom hours, and they have a book of knowledge or something like that kind of dictates what needs to be trained, but most of them don't have a certain amount of allocated time that needs to be spent for data analysis. And my experience in the industry is most of these training classes do not spend enough time on the analysis portion. You might scan a few welds, you might learn how to set up the instrument, spend a lot of time on theory, but maybe not really get deep into characterizing flaws, analyzing flaws, proper way to view multiple channels and cross-correlate defects, that kind of thing. And a lot of the data is bad. I've been with Veriphase 4 or 5 years now, and I'd say 70% or more of the data we get, we reject. It's just bad quality. Procedures aren't being followed, codes aren't followed. There's a lot that goes into phased array, good phased array, and that kind of leads into the next one. Pretty easy to do a basic setup, cover your volume, but there are a ton of essential variables that affect the outcome and how good that actual phased array data is. And doing a lot of trials, seeing a lot of data, seeing a lot of different approaches to setting up for very similar welds, I can tell you it varies a lot. So those essential variables are important, and the code also puts a huge emphasis on them, and that can almost be a burden in trying to document them, so that kind of ties in as well. The services are expensive, whether you're going out and paying for them directly, somebody come in and do phased array for you, or if you feel the need or have an obligation to have a third party look over their shoulder, review some of their data, review some of their calls. All that is not inexpensive compared to more traditional or conventional methods. And then a big one is it can just be very hard to understand. So unlike dye penetrant or a radiograph that looks like the weld, unless you've been through one of those rigorous training programs that teach you how to look at that data and kind of correlate it back to the weld, the images don't necessarily make sense to a layperson. So all these and tons more that we'll get more into detail, but these are kind of over-encompassing challenges that we'll see. On the left-hand side of the screen, you'll actually see kind of one of our mantras. It's SCORE. So focus on these things, because in NDT and in most businesses, these are the key elements. So it kind of encompasses that schedule, cost, safety, compliance, reliability, efficiency. I mean, anything that you can think of that is of utmost importance. I mean, when we're doing the actual task at hand, we think we have to analyze data, but these are kind of underlying things that are always there in the background that are of utmost importance to everybody involved. So when we design this, either the off-the-shelf ADT product that you can buy and kind of apply to your weld inspections today, or we're coming in and we're providing an industrial enterprise solution more for a high volume manufacturer, what we try to do is we try to improve that whole workflow that happens within a phased array inspection, and especially focused on the analysis reporting side after the data is collected, in order to make sure, or at least increase the chances that the inspection is of highest quality as possible. So we try to automate the analysis process, the reporting process, checking for quality, try to automate as much of the compliance as far as documenting essential variables or checking essential variables, looking for quality control issues, that kind of thing. We try to increase the efficiency of all the processes. That might just be the actual finding of defects, the reporting of defects, the sizing of defects, everything, auditing of data, which can be very time consuming. And then the reliability. There's a lot of ways you can use ADT. You can use it as kind of a front end tool, or you can use it as a backup tool, just to have a second digital set of eyeballs looking at the data in different ways, on top of maybe the same time that you would normally spend doing an analysis or doing an audit or doing a report. You can have it do a very efficient scan check afterwards and just add to that reliability. And then reduce. So reduce liability, obviously, while increasing safety. Put your ducks in a row by having a software double check you. Because the thing is, data fatigue after you've been analyzing for a long time, or you've been on the same job for a long time. And as great as trained human technicians are, they are fallible as humans. So having a digital tool that you can pull out and use as well is a great way to reduce liability. Cost. So if you can save time, if you can avoid an error, if you can find another way to use the tools within ADT to reduce your either cost you're paying, or you can maybe charge more providing a service with an advanced tool like ADT, just factors in on that cost factor, and then time. So ties in with that efficiency side. Save time on every part of the phased array analysis process. So we look at just kind of a general overview. So right now the ADT program is really broken down into these main components. And when we talk about ADT right now, we're talking about normally phased array, weld inspection, carbon steel, single V, double V type components. We have a whole laundry list of expansions to that coming hopefully in the near future. And right now the current off-the-shelf ADT program is geared around the OmniScan. We are working with other instruments and data right now in order to expand that. And of course customization to the enterprise clients as well. But no matter what, the environment kind of looks the same to date. It's got these main components to it. So single weld and Prouty MultiWeld are two unique data processing that allow you to get through very quickly. We'll look at those in a different slide and go into these in more detail. Scan check, which really focuses on data quality, can be used by pretty much anyone, no matter what your knowledge of phased array is, for an audit tool. Kind of automate some of those processes that would normally require you to open a file and dig through them and have some more knowledge of what you're looking for. Report updater, which just helps get through that tedious reporting process. Data viewer is kind of a unique one in the fact that it's an interactive data viewer that does some things that the basic OmniScan platform can't do by itself, or the OmniPC platform, and allows you to take very large data, make it much more portable, communicatable, and view the data in some interesting ways. And then usage reporting, which I haven't made the video for that one yet, but it's kind of our online component, so it's not actually in the ADT software, but that's actually a place where you can, if you're in the ADT environment with multiple users, you can run reports on their usage by different metadata, megabytes, length of weld, date, that kind of thing. So we'll get into all these at some point. We're going to focus on the top 5 in the first 5 videos. We might come back and do a usage reporting, the online component, at some other time. You can see by the little graphic I chose on the left, it's just trying to symbolize a little bit how all these kind of work together. So ADT is not just for the technician, the guy in the front lines doing the actual inspection. We've actually built these that most of these, especially scan check, could be used by somebody, or data viewer as well, could be used by somebody that maybe isn't fully trained to do phased array, kind of all interactive levels, and also people within an organization. So you might have some level 2s that can send data over to a level 3 for peer review, and the data viewer comes in there, and be able to have these employed within your organization, multiple licenses, and everybody kind of using the tools that fit their particular job. So here it is in the actual ADT environment that you'll see throughout the videos, and kind of just broken down into 4 basic categories. So either single weld or multi-weld processing kind of speak for themselves. Sometimes you just want to get down to it and figure out what's going on with a particular weld. Multi-weld kind of brings a new element into it where you can batch process. Really no limit of welds depending on your computer specs. And be able to get kind of an industry first analysis planning instead of going in blind. I think you'll really like that. It's one of my favorite components. We'll go in deeper as we get into the multi-weld video. Automatic reporting, interactive viewer we mentioned, and then kind of the more just focused on quality. The interesting thing about scan check is we've actually taken a lot of the data quality parts out of that, and we've put them into these other components. So just because you're running single weld, multi-weld, report updater, data viewer, doesn't mean you're not getting that scan check component of data quality. That's actually interspersed in without it. The standalone module of scan check is really made for those people that might not have the in-depth knowledge or just want to run the quick data audit either on a single weld or a batch of welds without having to open them, dig through them, or maybe they don't have the experience to do that manually. So look at it a little bit deeper, and again, we won't go too deep in this overview. We'll try to keep it brief, and we're going to go into these in detail, just get a few images and a few bullets. But again, scan check's that audit tool, really focuses on data quality assurance, procedural compliance to some of the major codes. It allows you to do that very efficiently without opening files, gives you flags on specific code issues, documents all that for you, provides some images of it as well. Single weld processing does some upfront consistency checks. There's a lot of common errors where people say they inspected from both sides of the weld, but maybe they forgot to change 90 to 270. So we do some upfront stuff, and then we also give you immediate indication table back into the OmniPC environment, and then allow you to have kind of focused analysis, quick disposition of those, where you can kind of click and fly, and the OmniPC software is going to change displays, as well as place the cursors on the width and the height positions on the flaw. MultiWeld Processing, again, that's kind of an industry first, where you can look at, from anywhere from 5 to 300 or more welds, all kind of collectively, and have this analysis planning sheet on top of all the file copies and all the individual reports. So you're able to kind of sort through this, so you can kind of take your whole job as one and decide, okay, how long is it going to take, which normally you can't really tell up front. Do I have any quality issues that I need to address before I dig into doing the analysis? And then also, is there any way that I can take care of the particular welds that have maybe a lot of flaws before I'm 8 hours into this, or 3 hours into this, or 2 hours into this, and feeling a little bit of data fatigue. It just lays everything out for you. So again, we're going to dive into that in a bigger snapshot when we get into the video. Report updater is exactly what it says. So after we save the file, after doing your final human analysis, after the ADT analysis, it just expedites that analysis reporting. Puts automatic images with the flaws in there, automatically extracted. Gives you some quick stats where you can find and kind of sort through the data, especially if you have a lot of indications. Pulls out a bunch of essential variables, and then also does that quality checks as well. So that's a very interesting one as well. And then the data viewer, which is kind of unique. Most of these things you're probably used to. I mean, you have to do reports, you have to do analysis. But this one's kind of unique, and then we actually package that data up. We take it from, several megabytes down to kilobytes, put it into a different file structure, and allow you to view it within this tool, which makes it, emailable, not having to upload and download files. Very communicatable to people that might have to do the repair, different ways to view the data, different ways to automatically merge the data. We have to even play it like a video. So a lot of unique ways on there, and a module that we're sure to build upon as we go. And then the data metrics. So I haven't made this video yet. The rest are done as we speak, but this is kind of the online component. So on our website, we actually host this, where if you're an administrative user of ADT and you have a team of ADT users, you can actually go there, pull reports, look at your data usage in different ways. Allows you kind of continuous improvement. I mean, this could even be used to compare shifts or technicians against each other, or monitor users and process in different ways. And it's really expandable to specific needs. If you're an enterprise type client where you might want us to track different metadata at different times, we could expand upon this. So it's kind of the online component that backs all of the rest of the ADT program up. And that's really it. So it's really just that short overview we wanted to do today, just to kind of give you the general overview or the umbrella of the ADT program. And as we go, we'll be going into each individual component. Thanks again.